We're looking for a volume of a solid. I'm reading through here. The structures that are the boundaries of this solid are a sphere and a cone. So this is going to lend itself really well to spherical coordinates because those two things are pretty easy to express using spherical values. So let's start with the sphere. X squared plus y squared plus z squared, well, that's rho squared, equals z. Well, z is rho cosine phi. I can divide both of those by rho with no problem. So I get rho equals cosine phi as the equation of that sphere. And that's nice, but I don't relate to that very well. I'm not sure where that is. So I'm going to look at the sphere in its rectangular form, see if I can figure out where it is. I have x squared plus y squared plus z squared. I'm going to subtract the z over here with everybody else, equals 0, and then we'll complete the square with the z. So coefficient of the z term is -1, divide it by 2 is -1/2, square it is +1/4. So I'm going to be adding +1/4 on both sides. And when I factor, I'm going to get z minus 1/2 squared. So this is a little sphere sitting not at the origin. Its center is 0, 0, 1/2. And radius, 1/4 is r squared, so radius is 1/2, which means the diameter is 1. So it's just little, it's sitting right on the origin like that, my little sphere. Let's look at the cone. So cone is z, is the square root of those spherical coordinates. X squared, x is rho cosine squared theta sine squared phi is x squared. Y squared, y is rho sine theta sine phi. It all fit. I'm going to notice I have cosine squared theta plus sine squared theta, so I'll factor that out, use the Pythagorean identity. That's 1. So what's left underneath here is rho squared and sine squared phi, which is pretty convenient to take the square root of. I can divide both of those by rho. Now I have cosine phi equals sine phi. Well, the place where that happens, where my sphere is going to intersect with my cone, is above the xy plane. And that happens when phi is pi over 4. So my cone has its vertex at the origin. It goes out like this. And I end up with, it's a little snow cone. A cone with a sphere on top of it. So I'm looking for the volume of a snow cone. Theta is going to go all the way around because I want the entire sphere, the entire top half of the cone. So let's set up, now that we know what we're dealing with, let's set up some limits of integration to find the volume of this thing. We'll do rho first. Rho starts at the origin, and I'm going to go outward until I get to the other side of the solid, which at every location here is going to be the sphere. So rho goes from 0 to the edge of the sphere. Phi goes from 0, so that's the z-axis, to the cone, again at every location in this solid. So that's 0 to pi over 4. And theta, I want the entire thing all the way around 0 to 2 pi. If I'm in XYZ land, to find a volume, I'm going to use 1 as my integrand, 1 dx dy dz. In spherical land, that translates to rho squared sine phi d rho, make sure my order matches, d phi d theta, and we're set and ready to integrate. I put theta on the outside, but I'm going to look all the way through here at the other limits of integration at my integrand. There's not a theta to be seen anywhere. That means when I integrate with respect to theta, I'm just going to get a factor of theta evaluated from 0 to 2 pi. Well, 2 pi minus 0 last time I checked was 2 pi. So when I integrate with respect to theta, I'm just going to get a factor of 2 pi. There it is. Now, I'm going to integrate with respect to rho. Well, the integral of rho squared is rho cubed over 3. So rho cubed, I'm going to put my 1/3 out here. And rho cubed evaluated at cosine phi and 0, well, 0 cubed is 0, so that's not going to produce anything. I'll just have cosine cubed phi. Let's see, so we've taken care of rho, we've taken care of theta, that's d phi. So I have one integral left, one variable, just phi, and this is something that we can use substitution for. I'm going to let u be cosine phi, which means du is negative sine phi. So my integral is u cubed du. When I integrate that, I get negative u to the 4th over 4. So I'm going to take that 1/4 and put it out here, multiply by the 2 pi over 3. So 2 pi over 12 is pi over 6. And I'm going to substitute back. This is negative cosine to the 4th of phi. And I'm evaluating at 0 and pi over 4. So pi over 6 times, let's see, cosine of pi over 4 is root 2 over 2. And I need that to the 4th power. Root 2 to the 4th is square root of 16. 2 to the 4th is 16, so that's a 4th negative. Cosine of 0 is not 0, so we do have to think about this. Sometimes you see the 0 down there and go, oh, don't care, but we care because cosine of 0 is 1. So I'm going to have minus negative cosine of 0. Carefully keeping track of all the signs. So positive 1 minus 1/4 is 3/4. For a grand total of volume of pi over 8 for this solid.